These are generally published initially to give the idea of what is the specific terminology and methodology behind a particular approach. So, in case of an SNMP V3, these five RFC numbers were being published, and these five RFC numbers were corresponding to some of the specific applications which are wait a few minutes, I'll be right back. Okay, so what was I saying? I was discussing about RFC numbers. So here, these five RFCs are proposed in context to the uh, basic idea which is there behind SNMP V3. So in case of the 3, 4 and 5, the 3, 4 and 5 factor, the 3, 4 and 5 RFC numbers are basically the ones which are in context to the applications which are supporting the SNMP V3. So the fourth and 5, which is 2274 and 2275, we had already discussed about the excess modes which are normally proposed. However, instead of going on to the basic excess models, SNMP V3 proposed the combinations of those excess models and the security models which are proposed in conjunction to these. Okay, so as seen from the figure over here, you cannot see the PDF.
Jamboard is visible.
Okay, okay. Is it visible now? Fine. So here what is being notified is the figure over here illustrates the basic idea which is behind a SNMP V3 security features which are being proposed. So what happens over here, since this is just a modified version of the traditional SNMP system. So what would happen? There would be a manager and there would be multiple agents. Clear? So the manager which is being given over here can be referred as a principal. Okay, so instead of specifically saying that it is an SNMP manager, we are normally terming the component as a principal. What's the need of giving it a specific name is, since we have already said that the SNMP manager is the sole entity which sends in the messages to the agents. If I name it as a principal, what can I do is that I can refer it as either an individual or a set of individual. So naming any entity as principal instead of naming it as a network manager or a specific manager. This gives you a generalized idea of any entity which is there into the system. Okay, so you'll have a principle which basically governs SNMP v3. मुझे दे देना मैं जा करके वहाँ पर चली जाऊँगी आप फोन लगा लीजिएगा मुझे फिर कहाँ जेपी के पास से तो जाना है डायरेक्टर सर के पास हाँ डायरेक्टर सर के पास जाना है ना ठीक है मैं दे दूँगी बोल दीजिएगा कि एक लाइन तो जुड़ गई है उसमें और एक लाइन अभी भी टूटी है जो ऑफिस की मैं तुमको कॉल लगा लूँगी अभी क्लास के बाद ठीक है हाँ Okay, so we were going through the principle. So what I'll do, I'll explain it with proper jam. See, here what is done, you have an SNMP V3. Clear? This SNMP V3 has a specific component which is principal. Now, your principal can either be a specific individual or it can be set of individuals. Now, what does this individual mean and what is this set of individuals? If I compare this individual with a specific application, so let's say I have any application which is just for monitoring the mails. So you would have heard about PGP, you would have heard about POP. So all of these applications are used while sending in the mails. What is the usage of these applications is these are providing any specific security modules along with providing the end-to-end delay of end-to-end transmission of the messages. Clear? So now this principle normally does is that since it's an individual or a set of individual, you can say it as it is the part of the management system. Part of management system. Now, when you are saying that it's a part of the management system, what is the major role of the principal is this principal will issue the commands. What are the commands that it would issue? We already saw that the manager and the agents communicate with each other with the help of the commands. These commands can either be SNMP trap, these can be any commands like request and the response. So normally if I say it as there would be SNMP commands issued. Clear? So the overall idea of principal is that the principal normally issues the SNMP commands to the agents. So that normally happens in any of the SNMP module itself. How is this different in case of a version 3 is that based upon the relationship between the principal and the agent, there are certain messages invoked or certain security factors invoked whenever any principal and the agent communicate. Here, what is the basic idea in case of an SNMP v3 is that you will have to have a specific identity of the principal, also a specific identity of the target system. Now, based upon the communication protocols or based upon the relationship between the principal and the target agent, there would be certain security factors like authentication, privacy, and access control invoked so that P and agent can communicate with each other. Okay, so These are the security factors which are basically present in V3. Now, you would have heard about the thing that whenever two agents or whenever two clients communicate with each other, if they want to communicate with each other in a secured fashion, they would always need to be aware of the fact that these are the specific identities of the system and one client can communicate to the other. So this is a case where C1 and C2 are communicating. Okay. What is the traditional case how C1 and C2 can communicate? Your C1 would send a message to C2 and C2 would reply back. In what cases would C2 reply? If I say that I am entitled to receive the message from C1 and process it and send a reply, then I would accept the communication between C1 and C2. Okay, only then I would reply to C1. Now, what if C2 doesn't allow C1 to communicate? When would it not allow? If both of these clients do not trust each other. So, you would have heard of the concept where the keys are distributed between the clients. When the keys are distributed between the clients, it means that both of these clients trust each other. And once I mention my identity to either of the ends, C1 would have to mention its identity at C2's end, C2 would have to mention its identity at the C1 end. So there needs to be a common key which is being shared between both of these. And only then, if any communication is happening between C1 and C2, it would be authorized and it would be established. Clear? So once C1 and C2 trust each other, similarly, when both principal and the agent trust each other, have a common key between each other, only then the communication would be established and further data transmission would happen saying that I have authorized or either of these entities are authenticated and obey the privacy rules. And only then I can communicate and do the data transfer. Clear? Any doubt?
No, ma'am.
Okay. So in case of a normal SNMP V3, this relationship is established between the principal and the agents. Now, when these relationship is established, the factors which need to be monitored is authentication, privacy, and final, we have to identify the access control. So these are the three basic factors which need to be considered in case of SNMP V3 to have a valid communication between principal and the agents or valid communication between the network manager and the agents. Okay. Now, the most important thing which comes over here is that what are the basic functioning of any SNMP entity which is there. So for that, what is done? You have been said that an SNMP entity is the major component which includes all of the SNMP engine. Okay. So here principal was an SNMP entity only. Okay. Now you have some management functionalities running into the system in each of the components of which are there into any SNMP organization or SNMP enabled system. So what happens is that you have an SNMP entity which basically is said that you will be having two sections. So this is a SNMP entity, and within an SNMP entity, what would be there? There would be certain applications which are running, and each SNMP engine would be also running into it. Okay, so let's compare this with the analogy of any principle. Okay, so if I compare an SNMP entity and make it similar to a principal, what would be the applications which are running? Since the major functionality of the principal is that it would be sending and receiving messages from the agents just to identify the status of the network and to identify the status of the client. Okay, so what messages were being sent? There were messages being sent for identifying any packets information, identifying the resources information. So what is being done? There are certain commands issued from the principal side. Clear? So there would be one module which is used in context to the application is there would be a command generator. Clear? There would be a component which is command generator that would send the messages to the agent. Similarly, you can have a command responder. Okay. This is in context to any of the commands or any of the messages which are being generated and received. Fine. Next is there can be one more component which is referred as notification receiver and notification originator. Okay, so both of these are, all of these four are in context to the messages being sent and messages being received. Clear? Now, if I compare this application and I want the parallel components which needs to be part of the SNMP engine, what can be there? Since I'm saying that the SNMP engine is there, you would be requiring certain functions which are implementing sending and receiving of the messages, which are implementing authentication, which have the ability to process encryption and decryption of the messages, which has the ability to control the access of the managed devices. So all of these are important part of the SNMP engine. How are both of these related? These applications are only focused upon identifying the general view or identifying the user UI for a particular application. However, the SNMP engine focuses upon how to process or how to deal with the communication establishment between P and agents. Okay, so I said that your SNMP engine is basically focusing upon implementing the functions for sending and receiving the messages, send and receive the messages, receive the messages. Next is we are implementing functions which are related to authentication. Then we said privacy also has to be referred. So privacy is in context to encryption and decryption of the messages. And finally, we said that access control also needs to be considered. For that, you'll say that controlling the access of managed objects. Okay, so same case, if I say that So same case, if I say that this is a SNMP entity, your SNMP entity will have applications and SNMP engine, and these are dispatcher, message processing system, security subsystem, access control subsystem. These are the subsystems which are implementing each specific function related to the messages, and the above are the ones which are in context to the application. Okay, so this form of SNMP entity is technically referred as a modular architecture of an SNMP entity. Okay, what are the advantages of having certain modular architecture? The first and foremost is that since the role of an SNMP entity is determined by the modules that are implemented in that entity. For example, you are having a certain set of modules which is required for an SNMP agent, whereas there are certain set of modules which are only required for the SNMP manager. So if I have a specific entity which would have multiple functions, depending upon at what site I would like to have that component, I may not need to have built up any other architecture. There would be one standard architecture within which I can have multiple modules that can be implemented. Since both the manager and the entity are actually nodes itself. So you do not need to have any specific hardware difference between both of these. Yes, since the functioning is different, since the SNMP manager is a higher hierarchy node, there would be additional functionalities which are added into the system. So that is why if you have a modular architecture, this provides you a better advantage. The second thing is that the modular architecture lends itself to defining different versions of each module. So there would be a case where it is possible to define alternative and enhanced capabilities for important aspects of the SNMP. So you do not need to go to a new version and develop any uh, newer architecture once again. You are already having a standard architecture. You could add in the multiple functionalities here itself. So let's say your SNMP v4 provides you any specific functionality which is related to security only. So what you will do, you'll just add one more component. You do not need to change the entire architecture of the system. Okay, so if you do not change the architecture of the system, this would provide you advantage as well in keeping the underlying user datagram protocol or any transport layer protocol in an intact version so that you can communicate the information using the standard SNMP only. We already said initially that the UDP layer or the transport layer sometimes can be used to communicate between the normal manager and the agent. So it doesn't say that only UDP can be referred. You can use TCP model as well for the SNMP communication. Okay. Next thing which needs to be discussed is we SNMP v3 message processing. So whenever any message is being sent, it is being sent in a specific format. So the underlying methodology or the underlying packet which is being used is PDU. We already discussed what is PDU, which is a user. What is PDU? It's a packet datagram which is normally containing all your plain text within it, which has the entire message, which has the entire information which needs to be communicated. Okay, now your SNMP basically relies on the UDP, and I already said that sometimes it would require transport layer protocol as well to convey the information. Now, if you're using UDP, your SNMP is organized into two application level layers. First is PDU and the other one is the message processing layer. So this one is the PDU and the other one is the message processing layer. Okay, so the topmost layer which is there is the PDU processing layer, and at this particular layer, what happens is that there are the commands which are in context to the messages like get, set, uh, response, get, set, trap, inform. All of these commands are realized in this particular scope, and there are certain variables which are used in context of these and are stored at this end. Okay. Now, when a particular PDU is set, you are sending it, since it is in context to the, it is being sent to a particular client or a particular agent, you would be requiring any other add-ons as well into the specific PDU. Okay, so the figure here shows that there are various information like message processing model. So this message processing model adds 5 more fields into the outgoing messages and are then processed by the message processing model on the incoming messages. Then you have these 6 factors which are used in context to the USM, which is user security model. These are generally used in any of the security model, and whenever any outgoing message or incoming message is being invoked, then all of these security services are provided by the standard SNMP format. Okay, so as seen from this, I guess it is very clear message version would be in context to the version which we require. Then we have message ID. So this message ID is basically termed as it's a unique identifier which can be used between two SNMP entities to coordinate the request and the response messages. Normally, the range of this message ID is between 2 to the power 31 minus 1. So since it's a very unique identifier, you need to keep track on the of the sent and the received messages. So a request and the reply of matching is normally done on the basis of message ID. Then you have message maximum size, which is in the range of 484 to 2 to the power 31 minus 1. So obviously, as the name says, it conveys the maximum size of a message in octets. So generally, octets is supported by the sender of the message. So this is maximum segment size that the sender can accept from another SNMP engine and receive it. Then you have message flags. So message flag is normally used in order to store the information which is in the form of a bits. So here it the entire information is in the form of an octet string. Okay, so octet string here generally takes the information in context to 3 flags. One is referred as reportable flag. This is written over here. So the one is referred as reportable flag, private flag, and the authentication flag. So as it is said that here it's a, that if your reportable flag is 1, then the entire PDU should be returned to the sender. If your when the flag is 0, then the report PDU may not be sent. If the reportable flag is set to 1 by the sender, all the messages containing a request or inform and set to 0. So you can go through the combinations which are required, which are set up in these entire message flag. So depending upon the values of these 3 flag bits, authentication and encryptions are supported. Next is your message security model. So this is also any identifier which is there in the range of 0 to 2 to the power 31 minus 1. This normally tells you that what security model was used by the sender to prepare the message. So normally what is referred is that if it is SNMP V1, then it would be sent as 1. If it is V2 on any different version in V2, it would be set as 2, and if it is V3, then it would be set as 3. Now, the other factors which are there is we discussed that these are the only ones which are in context to the message processing model. The other factors which are there is in context to the user security model. So basically, this is the one which is in context to providing the authoritative engine. Okay, we have already talked about authentication. This one would talk about authorization. So if in any message transmission, you would be requiring transmitter or a receiver, and you'll also have a dedicated authoritative engine. Okay, now based upon the authentication done, there would be messages being sent and the payload would be generated and there would be a reply expected from either of the end, either from the sender or from the receiver. Now, generally, whenever any payload is sent, the payload normally has the information like it has the messages in context to get next, get bulk, set, or let's say inform PDU. In that case, then the receiver of such messages is termed as that the receiver is authorized. Okay. The other case can be when an SNMP message contains a payload and does not expect any response. When would it happen? When you are sending any SNMP V2 trap or any report PDU. In that can ask in the next class. Okay. So the other thing, since we are talking about the uh, communication between P principal and the agent, and we spoke about that. The authentication needs to be done on the basis of the exchange of the information, or you'll say that there needs to be a secret key which needs to be shared by both of these entities, and only then you would say that the communication is valid. So here the secret key authentication mechanism is being provided by TES. Clear? So what happens is if I go with the traditional cryptography, you have one case where you'll use one key for encryption, you'll use another key for decryption. Okay? So let's say if I'm using K1 for encryption, what would I use? I'll use K2 for decryption. So here both K1 and K2 are unique. Now neither K1 is aware of K2 nor K2 is aware of what is the value of K1. Okay. The other case can be I'll only use one key. If I use one key, in that case if I use K for encryption and similarly I for decryption what would I use? I'll have to use inverse of K. Okay. Now, how do I evaluate the inverse of K? In that case, what is done? Both the sender and the receiver would agree upon certain terms, agree upon certain values, which will be sent from the client, from sender to the receiver, or from Alice to Bob, and both of these sites would generate that key. So that when they generate the key, both of them generate the same key which can be used for encryption and decryption. This normally happens in case of a secret key, it's authentication. Because while communicating or while sending the information from Alice to Bob or while sending certain parameters, we assume that whatever parameters are being sent from both of these clients, these are normal parameters. So even if there is any twist or any tweaking in the values, the intruder cannot identify what is the actual key. Okay. So the basic idea of having a secret key authentication is that The keys are normally generated at both of these ends. I am not sending the key in the transmission channel. So if I'm not sending the key in the transmission channel, even if the intruder is trying to eavesdrop my channel, find out what is the key which is being transmitted, he will not be able to find the actual key because I am only sending certain numbers which will be used to generate the key. Okay. Now, in case of a secret key authentication, which is normally there in an SNMP v3, the authentication mechanism here assures that the received message was transmitted by the principal, whose identifier appears as the source in the message header. In addition, the mechanism assures that the message was not altered in transit and it was not artificially delayed or replayed. This is the same thing which I told you currently. You'll not send the actual key, you'll only send the values which are being used for generation. Okay, now there are some basic terminologies as well. So, uh, first is plain text. Everybody knows what is plain text. Any of the information which is present in raw format and which is the actual message is referred as your plain text. Okay, you have ciphertext which is generated after applying any encryption algorithm onto your plain text. Okay, now there are multiple ways of generating a ciphertext. What can be done? One standard way is I have a plain text, let's say, um, so let's say I have a plain text A, B, C. This is my plain text. On this, I apply a value K1. Okay. The ciphertext which would be generated would be A, B, C slash. Fine. How would this ABC slash can be generated? There are multiple ways of generating it. One way can be, let's say this is a key K1 which is being individually applied on the individual characters of the string. So on A, if I add K1, then this A is generated. On B, if I add K1, then this B is generated. C plus K1, then this new C is generated. And similarly, if I'll go for decryption, what would I do? I'll apply same, let's say I applied K2 and ABC dash say I generated ABC. So if I applied plus over here, I would apply minus over here. Clear? So this is one form of generation of the ciphertext. So here what is being done? This was my entire stream of plain text. In this entire stream, I applied the key and generated the text. Clear? One is referred as stream ciphers. Okay. The other ciphers can be, one is referred as block ciphers. Now, in case of block, what I'll only give you a specific idea what is there in case of block. Let's say the message which needs to be encrypted or the plain text which needs to be encrypted is of size 256 words. Okay. Now, if I apply the key on 256 words, that would take a larger amount of time. One approach can be, since and also it is not possible that every system has the capability to process 256 words at one time. It's not necessary that all of those 256 words can be represented easily. So in that case, what would be done? The entire message would be broken into some blocks. So let's say this is one block, there would be one more block, there would be an other block, and then would be. Now, let's say there are four blocks which are being generated. Now, on these four blocks, there would be keys applied, which finally would result into ciphertext 1, ciphertext 2, ciphertext 3, and ciphertext 4. Now, this completely depends upon the algorithm that how is that this key applied onto the initial plain text block. Okay. Once the ciphertext is generated, we'll combine this ciphertext block and finally say that this is the ciphertext corresponding to the plain text which is generated. Now, there are many other ways as well how a block cipher is generated. Sometimes block ciphers are generated on the basis of previous ciphers as well. So let's say this is a cipher which is generated by applying K1 key. Now, uh, if you need to find out the next ciphertext block, you might use the reference of the previous cipher which is generated as well. So these are certain methodologies which are used in generation of a block cipher. Similar methodologies are there into a DES algorithm as well, which is used in order just to generate and just to identify a specific key which can be used for authentication between the client and the agents. Okay, here your clients are referred as SNMP managers only. So if I come to the actual basics, what is there is if I come to the actual basics, you can say that in case of encryption algorithm or the conventional encryption which is used in SNMP v3, we are using DES and the cipher blockchaining mode is used in DES. Okay, so this entire process I'll tell you in detail in next class that how the ciphertexts are generated in DES and how are they used in case of a SNMP v3 version. Okay, any doubt till now? Okay, yes. See, for a specific topic, you'll require a specific book. Topic which I am teaching, it is not there in either of these books. Yes, SNMP V3 is not there. These books are very old books and you need to be updated in case of computer networks. Okay. So as of now, initially which the topics which I told you like Mac, DAC, these are there in Williams Stallings. Mac, DAC and RBAC. These are there in William Stalling. I guess the chapter is second or third, uh, which talks about access control. Okay. Uh, then the documents which I am sending you, these are not there in your books. So it is not necessary that you have to be stick. You need to be sticked on to those books itself. The curriculum is flexible and it is not necessary that whatever has been specified in the curriculum that everything will be covered. Be some modules which are not written into that and will be covered in extra. Okay. This I've already sent you. Previous also I've sent you. Only one is remaining, which yesterday the DAC and MAC. I've already shared you all the documents.
So, ma'am, when you take the papers, we have to refer these slides.
Okay, when I'll be sending you the minor examination, yes, you'll have to refer these slides. You'll have to refer these documents. Your other subjects examinations, when are they scheduled? Okay. We started on 21st September, right? Mm. So let me complete this SNMP V3. So I'll complete it by tomorrow. Then next week, your dates are 27, 28, and 29. Okay. Um, so should I take the exam on 27th or should I take it on 28th?
Yeah, 28.
You guys comfortable in? If you don't have 28, fine, then I'll take it on 28. Objective. No objective. No objective. Okay, so I'll not take quiz. I'll directly take a minor examination of 20 marks. Topics would be everything what has been taught to you till now. Fine. And it would be on 28th. Maximum marks I've already told you it is of 20 marks. Okay.
Okay, ma'am. Okay.
Anything else? Okay. So we'll meet tomorrow. Okay.
Thank you, ma'am.